Find the center, vertices, foci, and the asymptotes of the hyperbola. Well, the center is very easily identifiable because you know the standard form. You have the standard form memorized. I mean, it's x minus h quantity squared over, in this case, parabola. We could just keep the a squared there, minus y minus 6 quantity squared over b squared is equal to 1. Oops, I said y minus 6. I meant y minus the letter k. And so you could easily identify the center. The center is parentheses -9 comma 6. It'd be nice to be able to find the vertices. With this standard form, the two hyperbolic branches open left and right. So the vertices are here, and the foci are located right there. So they're all going to have the same height. And of course, the center is right here, the little blue dot or blue star. The center, we already know, is actually -9, 6. So there is sort of a rough sketch there. If we zoom in, we can actually get a rectangular box. What do you mean? Well, there's actually a rectangular box right about here with the blue star. Blue star is -9, 6. And we need A to be 3. So over here, we can draw a little triangle here. We could actually draw one of the vertices. You have to go 3 units to the right. So we have -9, 6. And if you go 3 units to the right, then we're at -6, 6. So one of the vertices is -6, 6. And if we go 3 units to the left, we get the other vertice as well. We get -12 comma 6. So we got the vertices that way just by drawing a really, really rough sketch of things. Vertices is -12, 6. And -6, 6. I should probably write my grammar correctly, because there's 2. We would say R. There we go. Now, it'd be nice to find the foci and the asymptotes. Well, with every hyperbola, there's this little rectangular box where it's 2a units wide and 2b units tall. So why don't we locate another ordered pair here? Let's locate this ordered pair. Well, we need to go, what? 4 units. I'm sorry, we need to go 7 units up. So we have, from here to here, it's 7 units up. And from here to here, this is 3 units this way. So one of the asymptotes is this black dotted line. And so it has a slope already. Let's call this asymptote number 1. It has a slope already. That slope is 7/3. So y minus y1 is equal to m times x minus x1. And we're going to go ahead and use the center to be x1, y1. x1, y1 is going to be the center, which is equal to -9 comma 6. So we have y minus a 6 equals 7/3. We have what? X plus 9. So there's an equation of one of the asymptotes. And if you wanted to, you could put this in y equals mx plus b form. It's not a problem. So we're going to add 21 and then add 6, so 27. So there's one of the asymptotes. Here's asymptote. The other asymptote would have what? The other asymptote would cross over, let's say this line right here, this blue dotted line. That slope is what? That slope is m sub 2, I guess. I can call this m sub 1. M sub 1 was positive 7/3. Let's find this m sub 2 slope. Well, it's negative now because it's pointing down. So you actually had to go down 7, right 3. And you could use the same, the same point slope formula to find the equation of the line. So y minus y1 is equal to now m2x minus x1. And x1, y1 here is just the center of the hyperbola. So y minus 6 is equal to negative 7/3 x plus 9. And once again, you could put this in y equals mx plus b form. This time we have minus 21 add 6. So minus 21 add 6 is negative 15. And there is your second asymptote. So there are two asymptotes there. We so far have the center. We have the vertices. The only thing left to find are the foci. And finding the foci, there's a relationship. So finding foci, there's a relationship between a and b. C squared is equal to a squared plus b squared. And we have what? C squared is now, what's a squared plus b squared? That's going to be 9 plus 49, which is 58. And if you take the square root of both sides, we get the absolute value of c is now equal to the square root of 58. 58 is not divisible by 4. There's no perfect square in there. So we're going to just say plus or minus, just say the square root of 58. Jumping ahead of myself here. Just say the square root of 58. Now, how do you solve an absolute value equation? C is equal to plus or minus the square root of 58. We also know that c is greater than 0. It's always the distance between a focus point, between a focus point and the center. So c is greater than 0. That means c is really square root of 58. Make sure you are showing all these steps here, though. I'm going to circle that as if it was a final answer. You're supposed to replicate those steps. Now, that isn't the foci. So why don't I leave myself a little bit of room here? The foci is what? Well, the parabola is going to open, remember, left and right. So the foci has the same height level as the vertex. In other words, it's still 6 units up from the x-axis. So if that's the case, then we just keep the y value to be the same, and we move the x values. So let's look at the foci now. If we keep the x value, which is negative 9, and then add or subtract square root of 58, and then write comma 6, we should have the foci. So the two focus points is negative 9 plus root 58, comma 6, and then comma here, negative 9 minus root 58, comma 6. And there you go. You got the focus as well, or the foci, more than one. I'm going to circle this one. This one's the final answer, but make sure you're able to show all your work. We have everything. We have the center, we have the vertices, we have the two focus points, and we have the two asymptotes as well.